Okay. Good afternoon. This is the last session of the day, of the first day of the forum. And I hope, just to make sure you're in the right room, this is the machine learning benefits in production operations. So we're focusing more on the discrete manufacturing operations in this particular session. We'll be running this a little bit differently, just so you know the format. I'll be doing a short intro, introducing four panelists, and we have a prepared discussion for this particular event. So what I'd like to do is suggest that if you do have any questions, do you introduce them as we're talking, because we have probably a good hour or more of question and panel discussion format already prepared. Okay, with that note, thank you. So my name is Sal Spada, and I'm from ARC, and I'm one of the discrete automation analysts that cover the production systems and discrete manufacturing. So what I'd like to first remind you, certainly with silence your cell phones for the duration of this period, and then if you have any questions, in this case, I would like you just to simply acknowledge that you have a question. I'll have somebody get to you with the microphone, and we'll try to interject it into the conversation. The other thing is we do have an app. I don't know if you've all downloaded it, but certainly download it. And what you can do is rate this session. So we really appreciate that kind of feedback, good or bad. It's not all about likes here. It's all about the truth. So with that note, really like to start talking about where the discrete manufacturing has been from my perspective. A lot of people here have been talking about this digital transformation, digitalization, and industrial IoT. And from my perspective, it's been going on a long time. And I go back almost 30 years, and even 40 years. And you look at things where I kind of model it as originally was the digital divide. You had these digital systems in the design and in the planning stages, but that digital information never made it to the production floor. Different digital systems, paper systems, all made it to the production, were used on the production floor, and that's where problems occurred and also challenges were created as a result of lack of information coming back into the design system. So over the last 30 years, I think the divide's been closed. There's been convergence from the digital systems in the design and planning world, and they're now connected to most of the systems on the production floor. And that would probably be relegated to mostly the tier 1, tier 2 type manufacturers, but we have a lot of small and medium businesses that are really struggling to even make this convergence. But for the most part, we see a lot of this digital divide closed, and the gap as the only gap that remains, though, is what I call using the data on the production floor, creating data, and using it for learning systems in your operations. So the way I look at machine learning, it's the extensive use of data, statistical data, and analysis, and trying to explain the underlying systems in your production floor, through modeling and also making decisions using fact-based management. So I always use this type of explanation when I think about machine learning. It's about collecting information, repackaging it so that you can analyze it, and then developing learning algorithms that will identify behaviors that you weren't able to see under traditional information systems. And so where I look at that closure, the original diagram showed the digital gap closed. But for the most part, people aren't closing the loop on manufacturing. And this is where I see machine learning in this diagram playing a big role. Machine learning playing a role in the feedback loop from the production operations all the way up to the design and process planning. We're very important to understand the challenges that are faced on the production floor, whether it's materials, whether it's machinery, or whether it's people. It can be all three at the same time, or it can be one at another. The other facet of this, For the most part, this hasn't occurred, but I challenge a lot of people when I put this slide up, and I say, over time, as we start to learn about our production systems, we'll start to be able to use software to our benefit. And that is, we'll have software-defined machines. That is, we'll redeploy them while they're on the production floor to adapt to those machine learning systems. And so I would argue that the first software-defined machine was the Apollo 13, or that whole generation of satellites that were reprogrammed during their trajectory throughout the flight path. Of course, they were only using 4K memory, small 4-bit computers, and redeploying the algorithms throughout those flight paths. Today, what's Tesla doing? They're redeploying their software based on the behaviors of the way the operators drive their car, or how the cars are behaving in certain road conditions. So they're really tunable machines through software. And I eventually expect to see that continuous improvement be deployed in the manufacturing operations. And so what I really want to say here is there's always been a plateau that many companies have reached in their manufacturing operations. How are they going to, and what they really want to do is break through that plateau. So through machine learning techniques, I envision we'll have a new series of plateaus created, higher performance production systems through identification and automating the identification of problems and anomalies in the production floor through machine learning algorithms. So we want to really reduce the time for problem identification. I mean, you can imagine today that it takes possibly months. In many instances, you talk to many of the manufacturers, it may take some months to solve process problems. Now we'd like to shorten that time span through creating a data-driven environment that enables companies to identify the challenges they're facing in their production systems. But one of the other challenges they face, if you want to think about machine learning and deployment, is how do you connect to the equipment on the floor? You know, the number of standards and networking interfaces, or even many of the legacy machines don't even have interfaces. But you need to think about the cost of deployment and how we can improve the speed of that. And we have a speaker, one of the panelists today, really talking about those challenges that they faced in the integration of learning algorithms. But we already see learning algorithms deployed today because the computing systems have not gotten just cheaper and faster, they're just phenomenal. I mean, you look at this type of a vision learning algorithm that's on a production floor. They're using, you know, the NVIDIA deep learning GPUs that are now, you know, utilizing neural nets to produce learning systems so that it can train the robot on the optimal way to approach a part. So it's really learning on the fly. We see other systems, and this is a little bit more complex, but the idea is that we're pushing data into the cloud. And this model here is really driven by what occurs actually in the financial community, where they're using complex event processing that derives rules from big data that's been analyzed over a long period of time, and new rules are being deployed on the production floor so that companies can react or provide better procedures to their employees. So this is an example of one system that I've seen in deployment already that has employed that type of idea. So what we really want to look at, too, is what's the cost of downtime today? If you look at some of these systems, I mean, automotive plants, and this is probably low, it's probably $43,000 an hour or more. Some of the packaging operations, and we have a gentleman here from Church and Dwight who could probably refute me on this, but $15,000 an hour if you're thinking about making pills or CPG goods. So what we need to do is look at what's the benefit not only from deployment, but improving quality, but also reducing downtime and the cost of material and labor cost loss. So we really need to identify those optimal parameters for manufacturing. We need to predict equipment breakdown, which would be ideal. And we also need to improve the overall production performance. And we envision that machine learning systems will support these types of goals. But where I see the future of automation, in the left-hand corner in this diagram, you see what I look at traditional automation systems, whether it's a machine or a robot or a press or a packaging machine, but they all just fundamentally are pre-programmed systems that analyzed, act upon their sensor input, and perform a task. That's fundamental. However, what you want to see is we move up into the right-hand corner of that grid, where machines not only perform those traditional, aren't programmed traditionally, but also are acting more autonomously, adapting their behavior so that they can perform outside of the envisioned window of operation. And that would be ideal. Place a robot on the manufacturing floor, show it a part, and it will decide how it's going to pick it up. Then also the digitalization, the machine learning capabilities are also transforming the way machine builders will run their business. Well, they not only go from just developing, but shipping intelligent connected machines, but also looking for a way of providing additional services. And we've heard a lot about providing services. Some machine builders will even provide not selling machines, but selling output. But there's a whole new world of business opportunities for machine builders who start to adopt some of these machine learning and connected ideas.